Assalamu alaikum. Well, children, last time we proved two theorems, two congruency rules, side congruency rule and RHS congruency rule, right angle, hypotenuse and side congruency rule. We proved these two rules last time. Now today we have to do the application part of that. We have to solve questions from the exercise. The exercise therefore will be exercise number 3 of this chapter. Exercise 3. This exercise has 5 questions. A few of those questions we'll do today, and then in the next lecture we'll be able to complete this exercise. Let us begin question number 1. Diagram of the question you have on the textbook. You copy that, you draw that. I shall draw here in the meantime. Well, according to the statement, as usual, you will get two informations from the statement. You will get what is given to you in this statement and what is the required result, what we have to prove. Because we find the word show is written there, show that. So therefore, you have to prove some result. Sometimes we have the word find there. So there we need not prove anything, we have to find something. We accordingly write the words to find there. Here the word show refers to we have to prove something. So we'll write accordingly to prove in this. 4 results we have to prove in this question. So to prove we'll have therefore 4 parts. Now what is the given information with us? We have triangle ABC and triangle DBC. 2 isosceles triangles on the same base BC. Equal sides are given to you. Isosceles triangles are there. So 2 sides equal. I have shown those equal sides of this isosceles triangle by same mark. Short line 1 short line on AC and AB means these are equal. We have DBC also an isosceles triangle. So its 2 sides also will be equal. BD side and CD side are the 2 equal sides. These are on the same base BC. This is the common base of the 2 isosceles triangles. In the previous exercise also we had a question of the same nature, but there the 2 triangles were on the opposite sides of the common side BC, like this. Here these are on the same side. So that is the difference. AB therefore is equal to AC, we know it. BD is equal to CD, we know it. Vertices A and D are on the same side of BC. So this refers that the 2 triangles are on the same side of the common base BC. AD is extended to intersect BC at P. So what we have to do after drawing the 2 triangles ABC and DBC, we have to join A to D. And then after joining A to D, you have to produce that to intersect BC at point P. That is the given information. Up to that you have to write given. Now the 4 results to be proved. First part is triangle ABD we have to prove is congruent to triangle ACD. Second part, triangle ABP is congruent to triangle ACP. Third part, AP bisects angle A as well as angle D. And the 4th part is AP is the perpendicular bisector of BC. You write those one by one on your copy. We have to prove all those parts. Let us begin here with the proof of this. And we'll begin with the proof of first part as usual. We are asked to prove two triangles congruent. Triangle ABD, you can identify in the figure. Triangle ACD, you can identify in the figure. And for the sake of convenience, for making things simple, we'll roughly draw those two triangles here. This is the first. ABD is the name. This is a rough figure. Another triangle is ACD. This is the one. So these two triangles we have to prove congruent. And for congruency, as usual, we need out of 6 elements information about 3 with reasons. 3 elements of one triangle we must have equal to the 3 elements of another triangle with some satisfying some congruency rule. We have 4 congruency rules. We have SAS congruency rule, we have ASA congruency rule, and then corollary of that AAS. We have SSS congruency rule, and we have RHS congruency rule. One of the conditions, one of the rules, the 3 elements must fulfill. Then only we can conclude the 2 triangles congruent by using those rules. Now, what is the information available to here to us? We have AB equal to AC. This is clearly shown in the figure because the triangle ABC was an isosceles triangle. It is given to us. We also have BD equal to CD. This also is given to us. 2 short lines on both of these. Means they are equal. And then we have to look for the third information. Number of times we have done earlier, you can easily get that third information. They have a common side. AD is the side of both the triangles. AD you can see appears here as well as here. This is the common side therefore. Thus we find 3 sides of first triangle equal to, in length to the 3 sides of another triangle. And this is sufficient for us to conclude that the 2 triangles are congruent. That will prove our first part. Let us complete it. In triangle ABD and triangle ACD, we have AB is equal to AC. What will you write as reason? It is given. BD is equal to CD. This is also given to us. AD is equal to AD is the third point. Common side is the reason. With this we conclude the 2 triangles are congruent. Therefore triangle ABD is congruent to triangle ACD. We have used SSS congruency rule. The theorem we proved last time. Now having proved this, we will not directly go to the second part that we have to prove, but some results as per CPCT will get here. We'll apply, we need those results later. So therefore we'll keep those ready. We'll keep those ready. So that there will not have the problem when we'll go to different parts of this question. So keep those results ready. As per CPCT, you will have 3 more results. 3 more elements of one triangle equal to the remaining elements of another triangle. Corresponding elements. And those here for this pair of triangles will be in the form of angles. Because we have 3 sides already used. 3 angles are left. Here also 3 angles are left. Now corresponding elements will be equal. So therefore according to CPCT, we'll get angle A of this triangle equal to angle A of this triangle. Now as earlier said, you need not look at this rough figure, you have to look at the actual figure. And when we look at the actual figure, we don't have this A vertex here of only one angle. There are many angles having the same vertex A. So in such a case, we use the full name. Therefore, the name is angle BAD. We can also call it BAP. AD is extended to P. Therefore, angle BAD is equal to angle CAD. CPCT. This first CPCT result. Another angle at B vertex. will be equal to angle at C vertex. Full name will have to again give, because at B again there are many angles formed. At C we have many angles formed. So full name, angle ABD is equal to angle ACD, CPCT. And the third result will be angle ADB, though this will not be used anywhere later, but you can write it if you want to. Angle ADB is equal to angle ADC, again CPCT. That completes our first part of this. We kept 3 results ready also for application in the remaining parts. Over to second part. In the second part, we have to prove triangle ABP, it's the larger triangle here, ABP on the left side, is congruent to triangle ACP. Now, rough diagrams of these 2 triangles also will draw here. ABP is the first one. ACP is the second one. We have AB equal to AC. Then you can again see there is common side. AP is the common side. Previously AD was the common side. Now AP is the common side. This will be the second point. And then third, just now we have proved, according to CPCT, this angle equal to this angle. There we named it as angle BAD. But I told you can extend AD to P. So it will become angle BAP. Equal to, we wrote there angle CAD. Now it will be angle CAP. Thus we have 2 sides of first triangle and the included angle equal to corresponding sides and the included angle of another triangle. So we'll conclude again the 2 triangles are congruent. That will complete our second part. Let us do this part in triangle ABP and triangle ACP. We have AB is equal to AC, given to us. We are using SAS, so S will be followed by angle. Angle BAP is equal to angle CAP. We have proved it, proved above. Now what we proved earlier, to be precise, you write that result that we have proved, angle BAD we have proved equal to angle CAD there. This will make things more clear. And the third point is common side. AP is equal to AP. Common side. Therefore, the conclusion will be 2 triangles are congruent. Triangle ABP is congruent to triangle ACP. SAS congruency rule we have used. That proves our second part. And with this second part, we again will have proving congruency will mean you can use CPCT and you can again have 3 results. So far we have used out of the 6 elements 2 sides and 1 angle. Now what is left? Out of the sides 1 side is left. Out of angles 2 angles are left. Those also will be equal. Let us identify first the side which was left here. AB we have taken. AP we have taken. Which one is left? BP. And in this triangle, CP is left. So according to CPCT, we'll have BP is equal to CP, CPCT. We need this result later. We'll keep the mark 1 for it. We also have, according to CPCT, angle APB is equal to angle APC. This also is CPCT. Mark this second. And third result also will have angle at vertex B equal to angle at vertex C. That will not be required anywhere later, so better not write that. If you want to write, you can write. You will have to then give full name, angle ABP for it, because many angles are there. Angle ACP. Again, many angles are there. If you want to write that, you can write. These are the results I need for remaining parts. Then comes the turn of third part. In the third part, we have to prove AP bisects angle A as well as angle D. AP, this line, bisects angle A as well as angle D. We have already proved, written in the first part, in the CPCT part, that angle BAD is equal to angle CAD. We have used this also in the second part. These two angles we have proved are equal. Now when two angles are equal here, at vertex A, angle A is divided therefore by the line segment AP. By angle A we mean actually which angle? Angle BAC, the whole angle. It is divided by AP here into two parts, two equal parts. Means AP bisects angle BAC. But we are asked to prove that AP bisects angle A as well as angle D. Not only angle A, that we have proved. Just now I explain. AP bisects angle A. But we have to prove that it bisects angle D also. Now that bisecting of angle D by AP, we have not so far proved. To get that, you will have to prove these two triangles also congruent. Small triangles here. Left side triangle BPD, right side triangle CPD. These two triangles also you will have to prove congruent. Let us consider now these two triangles. In triangle BDP and triangle CDP, we have. To prove their congruency, let us draw these also in the rough figure. Rough part of the question. Triangle BDP, this one. Triangle CDP, and prove them congruent. Now for their congruency, what is the information available to us? We have BD equal to CD, this is given to us, first point. Again they have a common side, DP is their common side. And we have already proved here BP equal to CP, that will be the third point. Thus we find three sides of this triangle equal to three sides of this. BD equal to CD given to us. DP is the common side. BP equal to CP we have proved here. So by SSS congruency rule, these two triangles will be congruent. So what do we have? BD is equal to CD given. DP is equal to DP. Common side. BP is equal to CP. We have proved it. Therefore, we'll conclude the two triangles are congruent. BDP is congruent to triangle CDP. SSS congruency rule. And here by CPCT you can again get three results. We have used so far three sides, three angles will be equal. And out of those we need only one. So we'll write only one, will not waste our time. Which one? The one at vertex D. Angle BDP will be equal to here angle CDP. Full names, because again in the figure at D vertex we have many angles. So to make it particular, we'll give the full name. Therefore, angle BDP is equal to angle CDP. CPCT. Thus we proved these angles equal. This angle we have now proved equal to this angle. Now means that this AP bisects this whole angle at vertex D, angle BDC. Therefore, let us write AP bisects. Bisects means divides into two equal parts. We have proved angle BDP equal to angle CDP. They are equal. AP bisects angle BDC. Also, AP bisects angle A. This we have already proved. While proving the first part, we proved that this angle is equal to this angle. Again, CPCT you can see there. We then used that in the second part also. These are equal. Means AP bisects angle A. I have used it here. Angle A. Full name is angle BAC. Let us give the full name BAC here. And when we combine these two results, what will we get? Therefore, AP bisects angle BAC as well as angle BDC. These are the angles which have been named in short as angle A and angle D by using their vertices. We have given full names because at those points many angles are formed in the diagram. So that with that we complete the third part. Let us now finally do the fourth part of this question to complete this solution. Part number 4. In this fourth part, we have to prove AP is the perpendicular bisector of BC. AP is the perpendicular bisector of BC we have to prove. Means it is perpendicular on BC, makes an angle of 90, therefore here 90 degrees. It bisects BC. This bisect part we have already proved. We have proved BP equal to CP earlier. That was CPCT of second part. BP equal to CP means AP bisects BC. We have proved that. Now to prove perpendicular, we have to show this angle is 90. And to prove that it is 90, we'll use linear pair action. At P point, two angles are formed, adjacent angles, with their outer arms, non-common arms in the straight line. Therefore, they form a linear pair. You have already read. The sum of the angles, therefore, will be 180 degrees. We know angle APB plus angle APC is equal to 180 degrees. Write in the bracket linear pair action. We have proved it. And then we have also proved these two angles are equal. Angle APB we have proved equal to angle APC. Look at mark number 2 we have earlier put. Angle APB we have written equal to angle APC. I have just now rubbed that. We'll use that by substituting second. We get angle APB plus angle APB. I have replaced angle APC also by angle APB because we have proved them equal. APB equal to angle APC. We have proved it is equal to 180. Twice angle APB is equal to 180. Transpose to, therefore angle APB is equal to 180 by 2, 90 degrees. What does this mean, 90 degree angle? That AP is perpendicular to BC. But we have to prove perpendicular bisector. That bisector part we have earlier proved, right? Also, BP is equal to CP. We have proved it. Proved above. Which in turn means that AP bisects BC. Earlier we got AP is perpendicular to BC. Now we got AP bisects BC. The two results will be combined and the final result will be, therefore, AP is perpendicular bisector. Both results we have combined. Perpendicular bisector of BC. That completes the proof of this question. Question number 1 had 4 parts. We have completed those. Now over to question number 2. Let us keep question number 2 pending today. Let us conclude with question number 1 only. That is sufficient. If you understand that question, that is sufficient.